If fx equal to 1 by x, find f inverse dash of 3. So we have, let's start with the solution. Let fx equal to y. So x equal to f inverse y. But what is fx? It is 1 by x. So 1 by x equal to y. This implies that f inverse y, so x equal to 1 by y. So f inverse y will be equal to 1 by y. And that is the inverse. Now we just have to calculate f inverse dash of 3. So first calculate f inverse dash of y. That will be minus 1 by y squared. So f inverse dash of 3 becomes minus 1 by 9. Okay, let's move to the next question. Question 2. Evaluate integral 1 to e log x by x dx. So let's start with the solution. Start with let log x equal to t. So we have 1 by x dx equal to dt. What happens in a definite integral? You have to change the limits when you substitute. So when x equal to 1, t equal to log 1, which is 0. When x is e, t becomes log e, which is 1. So your limits reduces to integral 0 to 1 t dt, and that will be t squared by 2 within the limits 0 to 1. And what do you get when you substitute? You get half. Okay, let's move to the next question on definite integrals. This uses trigonometric integrals. So evaluate integral 0 to pi by 6 cos theta by 1 plus 2 sin theta d theta. So we start with the solution. Let 1 plus 2 sin theta equal to t. So we have 2 cos theta d theta equal to dt. So what will cos theta d theta be? It will be dt by 2. Now you change the limits. When theta equal to 0, t will be, sin theta is 0, so it is 1. And what happens when theta is pi by 6? T becomes 1 plus 2 sin pi by 6. Sin pi by 6 is sin 30, which is half. So you get 1 plus 1, which is 2. So your integral reduces to integral 1 to 2 dt by 2t, which will be half log t within the limits 1 to 2. So when I substitute, what do I get? Half log 2 minus log 1. Log 1 is 0, so this becomes log 2 raised to half. You can also leave it as half log 2. Let's move on to the next question. Evaluate integral 0 to 1 e raised to x by 1 plus e raised to x dx. So again we make a substitution. Put e raised to x plus 1 equal to t. So we get e raised to x dx equal to dt, and change the limits. When x is 0, what will be e raised to 0, which is 1. So t becomes 2. And when x is 1, t becomes 1 plus e raised to 1, that is 1 plus e. So your integral becomes integral 2 to 1 plus e dt by t. That becomes log t within the limits 2 to 1 plus e. And what do you get when you substitute? You get log 1 plus e minus log 2. And log a minus log b is log a by b. So this becomes log 1 plus e by 2. Alright, let's move to the next question. Evaluate integral 0 to 3 dx by x root x plus 1. Here you just stop at the limit stage. You don't have to actually integrate. So let's start with the solution. Put root x plus 1 as t here. So your x plus 1 becomes t squared. And what will be x? X is t squared minus 1. So when I take the differentiate, I get 2x dx equal to 2t dt. Now change the limits. When x is 0, t becomes 1. And what happens when x is 3? T becomes square root of 3 plus 1, which is square root of 4, which is 2. So your integral reduces to integral 1 to 2, 2t dt by t into root x plus 1. X becomes t squared minus 1 and root x plus 1 is t. So the t cancels and you get twice integral 1 to 2 dt by t squared minus 1. You can just leave it at this stage here. You don't have to go further. The basic idea is how to apply definite integrals. Now coming to Riemann sum. Using a midpoint Riemann sum with 3 equal width subintervals, find the approximate area of the shaded region. Find the approximate area of the shaded region. So let's start with the solution. So the shaded region is something like this. You have 0 to 6 here, and your curve is y equal to 6x minus x squared. You're given 1, 2, 3, 4, 5, and you're actually dividing it into strips here. You're using the left Riemann sum. So y equal to fx, that is 6x minus x squared, and we are dividing it into 3 intervals. So we can have 0, 2, 4 and 6. And your Riemann sum, your integral will be f of 1, that is the midpoint. Using the midpoint Riemann sum, f of 1 into the width is 2, plus the midpoint is 3 here for 2 to 4, the width is 2, plus the midpoint is 5 here, and the width from 4 to 6 is again 2. So substituting, you will get 5 into 2 plus 9 into 2 plus 5 into 2, which will give you 38. Okay, let's move to the trapezoidal rule. We have already done this in one of the earlier videos. So let's start with the question. The graph of a function passes through 4, 2, 6, 6, 7, 5 and 10, 8. Using trapezoidal rule, find integral 4 to 10 fx dx. So we are using trapezoidal rule here. So let's start with the solution. Tn becomes, we are taking f of 4 plus f of 6 by 2 into the width from 4 to 2 will be, so we take the width from 6 to 4, which is 2. So this is f of 4 here, plus then you get f of 6 plus f of 7 divided by 2, and the width from 6 to 7 is 1. So I took 4 and 6 and then 6 and 7 and then 7 and 10. So I get f of 7 plus f of 10 by 2, and the width from 7 to 10 is 3. Now f of 4 is 2 here, f of 6 is 6 by 2 into 2 plus f of 6 goes to 6. So it is 6, f of 7 goes to 5. So it is plus 5 by 2 into 1. 7 goes to 5, so f of 7 is 5, and 10 goes to 8. So 8 by 2 into 3. So simplifying, you get the answer as 33. Okay, let's do one simple question using modulus now. Question: evaluate integral minus 3 to 2 mod x plus 1 dx. So let's start with the solution here. Mod x plus 1 equal to x plus 1 if x plus 1 is greater than or equal to 0, that is x greater than or equal to minus 1, and equal to minus x plus 1 if x is less than minus 1. So I'll split this to integral minus 3 to minus 1. Between minus 3 to minus 1, it is minus x plus 1 dx. Plus integral minus 1 to 2, what is it? It will be x plus 1. Minus 1 to 2 means it's greater than 1. So now when you integrate, you get minus of x squared by 2 plus x within the limits minus 3 to minus 1 plus x squared by 2 plus x within the limits minus 1 to 2. So simplifying, you get the answer as 13 by 2. So we have learned a few definite integral problem solving in AP Calculus.